Let's say you need 5 volt for your phone or your Arduino Nano, but you have only 12 volt power source. So for example, you can use this buck converter from your car charger in order to step down the output voltage to 5 volt. So how these circuits work and can we build one? Let's find out. In a previous video, I've made a boost converter. As you can see, this buck converter uses the same components with a different configuration. The circuits work on two stages. First stage, the switch is on. The current will begin to increase, and the inductor will produce an opposing voltage across its terminals. This voltage drop counteracts the voltage of the source and reduces the output voltage. In the same time, the coil stores this energy in the form of magnetic field. In the second stage, the switch is off. The magnetic field collapses and keep current flowing through the load and the diode. So I test this circuit on the breadboard and I use a non-channel MOSFET as a switch. And my Arduino Nano as PWM signal generator. Then I use this potentiometer in order to control the duty cycle. I use my multimeter to check the output voltage. I upload the code. As you can see, we success to step down the voltage. But if we change the load, the output voltage also changes. So we need a feedback to correct the duty cycle of the PWM in order to keep the same voltage with different loads. The Arduino inputs cannot exceed 5 volt, so I use a voltage divider connect to the analog input of my Arduino. So now I upload the second sketch with the feedback and I use my oscilloscope. If I remove the load, the duty cycle changes. So the duty cycle of the PWM signal changes in order to fix the output voltage. All this just to understand how the buck converters works. There is a lot of integrated circuits has his own PWM signal generator and feedback. For example, I use this LM2677 with high current up to 5 amperes. The input could be in range of 8 to 40 volts. We just need to replace the resistor R2 in the circuit to get a variable output voltage. This IC needs just a few external components, so I solder everything according to the schematic. For more information, you can get the datasheet from the internet for free. So let's make it on PCB. 1 kilo ohm resistor, 10 kilo ohm potentiometer, 10 nanofarad capacitor, 23 microhenry inductor, 50 volt 100 microfarad, 16 volt 220 microfarad, the input and the output. And this is the final appearance. So you can make your own back converter. I hope you enjoyed this video. Don't forget to like, share and subscribe. Thanks for watching and see you next time.